Hi everybody, welcome back. This is Unit 10, Lesson 6, and it's the final unit and our final lesson in our Unit 10 notes. We will have a test on Unit 10 on Friday. And really, this section answers why things happen in life. Things being reactions and processes. There are really two driving forces for any process to happen. Either you have to lower your energy and be exothermic, or you have to increase your disorder. And so the first term that we have to talk about here is enthalpy. And enthalpy is the energy difference between your products and your reactants, okay? So we know enthalpy, we learned it in our kinetics unit, is delta H. And it is equal to the potential energy of the products minus the potential energy of the reactants. We also know that there's two possible conditions for delta H. Either delta H can be positive, and if delta H is positive, it's endothermic, or delta H can be negative, and if delta H is negative, it's exothermic. Remember, endo means more energy is absorbed than released, and exothermic means more energy is released than absorbed. Well, processes that happen all by themselves don't absorb energy because they'd be unlikely to happen, right? A lot of energy has to go into a process, it's unlikely to occur. But if not a lot of energy has to go in and a lot of energy comes out, it's more likely to occur. So there is a drive in nature to achieve a lower energy state. And if you achieve a lower energy state, then you're undergoing an exothermic reaction. Delta H is negative. Okay? So if the reaction is releasing energy, it's way more likely to happen than a reaction that has to absorb a lot of energy. Okay, so one reason things happen is to lower their energy state. That's a reason, okay? And what that means is delta H is negative if you're lowering your energy state. Another reason things happen is to increase what we call entropy. And entropy is going to be the title of my life story, I think, because what entropy really is disorder. It's chaos, okay? And believe it or not, things in nature want to increase their disorder. There's a fundamental chemical law. It's the reason you should never have to clean your bedroom again. It's because the entropy of the universe is constantly increasing. Okay? So you cannot fight it. There's always a drive in nature toward more disorder. And so you can clean your bedroom and put everything in its place, but inevitably it's going to become disordered again. And the reason for that is sheer probability. There is only one way for your room to be ordered. You know, like your socks have to be in your sock drawer and your pants have to be put in your closet or whatever the case may be. But there is an infinite number of ways for you to be disordered. So things will happen either to lower energy or increase disorder, increase entropy. Okay, so there's a tendency in nature to increase entropy. The equation or the symbol that we use for entropy is delta S. And so we want delta S to be positive. We want disorder or entropy to go up. Now, if a reaction has both these things true, it will always occur. It will always be spontaneous, right? If it's exothermic and the entropy is going up, it will always happen. If neither of these things is true, it will never happen. So if it's endothermic and the entropy is going down, that process just won't happen. You can't even make it happen. It will not occur, okay? If only one of these two things is true, then whether or not it happens depends on the temperature that you're at. And you don't really have to get any more specific than that. You just have to know that the two things in nature that tend to drive processes to occur, or the reason things happen, is to lower energy Okay, so a decrease in heat, a decrease in enthalpy, or increased disorder, increased entropy. Now, I think that's what we have there. A release of energy, delta H must be negative, or an increase in entropy, delta S must be positive. With regard to the phases, you should know which phase has the least entropy and which phase has the most entropy. Again, remember, entropy is disorder. All right, remember solid molecules? They're in their like regular crystalline structure and they just chill out and vibrate. Solids are highly ordered, which means they're not disordered, right? And if you're highly ordered, you have very low entropy. So solids have the least amount of entropy. The phase of matter with the most amount of entropy, you might guess it, where the atoms are like bouncing all over the container like pinballs in a pinball machine, that's the gas phase, right? Remember, gas molecules are just crazy. They're bouncing all over the place. Okay, they have no regular geometric arrangement. They move randomly. This has the most disorder. And so this has the highest entropy. Okay? And then obviously in the middle is your liquid. Okay? Because they're not ordered like solids. Remember, your liquids are your ballroom dancers. They're not ordered like solids. They're free to move about, but they just don't have as much crazy motion as a gas. So, solids have the least entropy. Gases have the most entropy. As you proceed this way, entropy goes up. Okay? Or you can think of, I don't know if you remember our heating curves. Solid, liquid, gas. As you go up the stairs, entropy or disorder increases. As you go down the stairs, entropy or disorder decreases. So, if you ever ask yourself, why does this happen to me? Why does anything happen? There's two reasons why things happen. Either delta H is negative, okay? You're releasing energy. You want to get to a lower energy state, or you're increasing the disorder. Those are the two driving processes for anything in the world, anything universal to ever happen. One of these two factors must be true, okay? If both are true, it's always going to happen. If neither are true, it's never going to happen. Okay? So that's the driving force, at least chemically, for why things in nature tend to happen the way that they happen. Like if you take an ice cube and you put it on the table, you know that ice cube is going to melt. Why? Why does it melt? Well, you're going from solid to liquid. So what drives the melting of ice is an increase in entropy. It's because the molecules are more disordered in the liquid phase than they are in the solid phase. Okay? That's what drives that process to happen. It's not exothermic, because again, with this heating curve, remember when you go up the stairs, those are all endothermic. Okay? When you go down the stairs, they're exothermic. So melting absorbs energy. All right? So not both factors are not true here. Only one is true. All right, so the tendency is to lower energy, be exothermic, and to increase entropy. Have a great night, everybody. We'll see you in class tomorrow. Bye-bye.